Hello, hi, good morning, guys. Good evening. Hi, Aishwarya, Prajwal. So, ಹೇಗಿದ್ದೀರಾ? So, ಹೇಗಿದೆ ನಿಮ್ಮ ಸ್ಕೂಲ್ಸ್? ಸೊ, ಮಂಗಳೂರು ಹೇಗಿದೆ ಐಶ್ವರ್ಯ? ಓಕೆ, ಆಸಮ್. ಮತ್ತೆ ಇದು ಎಂತ ಮಾಡ್ತಿದ್ದೀರಾ? ಓಕೆ, ಸಾರಿ, ಮೈ ಕ್ಯಾಮ್ರಾ ಇಸ್ ವಿಸಿಬಲ್ ಟುಡೇ, ರೈಟ್? Yeah, hi. So it's been a long time that I had turned on my camera. So I'm good, Prajwal. Thank you. So how are you? So hi Megana. Sorry, hi Mega, right? So ನಿಮ್ಮ ಹೆಸರು ಮೇಘ. Hi. ಹೇಗಿದ್ದೀರಾ? ಸೊ ಪ್ರಜ್ವಲ್ ಏನ್ ವಿಶೇಷ ಅಲ್ಲಿ? ಏನ್ ನಡೀತಿದೆ? ನಿಮ್ಗೆ ಎಕ್ಸಾಮ್ಸ್ ಯಾವಾಗಿದೆ? ಅಂದ್ರೆ ಏನಾದ್ರು ಐಡಿಯಾ ಇದೆಯಾ ನೆಕ್ಸ್ಟ್ ಎಕ್ಸಾಮ್ಸ್ ಯಾವಾಗಿದೆ ಏನು ಅಂತ? Okay, guys, I have launched a technical check. I hope you guys are able to see the technical poll. Please take the technical poll if my screen is visible to you guys and if my voice is audible to you. So, hi Tejas. Yes. So, in next class, so we'll discuss about electric field and potential today in our class for dipoles, and also we'll start with continuous charge distributions, and we'll try to complete this part so that from Monday onwards we can start with next part, that is electric flux and Gauss law. So electric flux and Gauss law, guys, tumba important concept though. It's the very important concept for you guys in this chapter. So hope that's not removed from your syllabus, right? Syllabus in the remove ಮಾಡಿದಾರ ಅದು electric flux and Gauss's law. Any idea like about the what's your split syllabus? Okay, that was done in your school, right? Electric flux ಮತ್ತೆ Gauss's law ನಿಮ್ಮ ಸ್ಕೂಲಲ್ಲಿ ಮಾಡಿದ್ರಲ್ವಾ? Okay. Yes, guys, come on, try to reply. Yeah. Okay, guys. Today, try to reply, try to be active. So yeah, please be here with me. You could help me solve many problems and everything. So we have some problems and some theory to be done for the dipole moment and dipoles. So in yesterday's class, guys, we checked for that electric dipole. What is the electric field due to a dipole? In a class, yeah, we checked for what is the electric field due to a dipole. So we'll have a quick revision, guys. Come on, reply in chat. So when we have a dipole, okay, did we complete that electric field due to a dipole yesterday for both the cases on the axis and on the equatorial point? Yes, yes, no, you don't really. Hi, guys. Hello, hello, guys. Hi, hi. Yes. Come on. Please try to respond. Okay. Um, yeah. So in previous class, we studied about electric field due to a dipole on the axis and on the equatorial point. So we'll have a quick revision on that. So please take this technical poll check, guys, faster, and try to call all your friends who are yeah, who are available. Just ask them to come join the class. So hi YouTubers, hi, good evening. So hope everyone is doing great. Okay guys, come on. So I'm going to end this technical check. So we'll begin the class. Okay. So in previous class we studied about electric field due to a dipole. Okay. Electric field due to a dipole. So what is the expression for that? What is the expression for electric field due to a dipole, guys? If you remember. So what is the electric field due to a dipole? It was k times of p by r cube or r square. How was my dipole? I mean, how was my electric field due to dipole varied compared to that of my electric point charge? Guys, how did it vary with respect to distance? Really, was it 1 by r cube or 1 by r square? Yes, it was r cube, 1 by r cube. For dipole, it was 1 by r cube. For point charge, it is 1 by r square. So the electric field due to a dipole, the expression for electric field due to a dipole on any given on the axis actual point and really it's like we have two charge particles plus q and minus q on separated by a fixed distance of 2a. On this axis, on the axis at a point r, we had to find the electric field. At this point, the net electric field E net was equals to this 2p or 4ar by 4 pi epsilon naught r cube or r per 4, sorry, this was supposed to be r per 4. So this was with neglecting my dipole distance of a. So what was the expression without neglecting a? So the expression for without neglecting a was a is equals to 4 q by 4 pi epsilon naught into 4ar by r square minus a square, where r was the distance from the point capital R to the midpoint of the dipole C. Hold on. So this was the expression for the electric field due to dipole, because without neglecting my small a, that is the for short dipole. So if you remember, excuse me. So this was the expression for electric field due to a short dipole. Now hope everyone remembers this, guys. Come on, let's in today's class we'll be discussing about the potential. So we'll discuss about potential in today's class. So what do you mean, what do you know about potential, guys? What do you know about potential? What is the general expression for potential? V equals to what is V, guys? Come on, tell me, what is my V? Reply, Madi. Electric potential for general point. Oi, Mega, yes, please. We are not in control. I mean, Karachi. Okay, what is electric potential, guys? Beko. Yes, correct, Prajwal. Correct. Okay, it was only Prajwal. Okay. Others, guys, try to answer me. What is my electric potential general formula? It is K times of Q by Prajwal. Even that was wrong, Alva. Only electric potential due to a point charge. Sorry, I was asking for electric potential due to a point charge. Okay, that was correct for dipole, Prajwal. Yes. Electric field due to a point charge is given by V is equals to KQ by R. How the guys, you remember this? Click on S if you know. Haley. Yes. So in today's class, we'll be okay. We'll be okay. This is okay. Now, okay, we had one more expression, right? The electric field due to a dipole in the equatorial point. Okay, this was the expression for the electric field on due to the dipole on the dipole or due to a dipole on the equatorial point of the dipole, neglecting A. And this was the expression which we get for the electric field due to the dipole on the equatorial point for without neglecting A. So we have to remember all of these guys. Please remember the end expressions. Okay. In today's class, we will derive an expression for potential. So what is the electric potential due to an electric dipole? So if we have a dipole, what is the electric potential? So guys, I think in your CBSE you have a different expression. You have different derivation. So I will try to simplify that derivation here. Okay. So what we are going to do? So let us consider. Okay, let us find what is the electric dipole or potential at the axis of the electric dipole. Okay, in today's class we'll discuss what is the expression for potential on the axis of electric dipole. So let us consider 2 point charges. So let's consider 2 point charges of same magnitude and opposite sign. Let V1 be the potential due to the negative charge and V2 be the potential due to the positive charge. So if V1 and V2 are the electric potentials yeah, if V1 and V2 are the electric potentials for charges minus Q and plus Q respectively, and if we consider a point R, so if we consider a point R in the region, okay, suppose yeah, if we consider if we consider point R in the region separated by a distance of small r from the midpoint of the dipole to the point R, then what could be the electric potential experienced at this point R due to this dipole, guys? Tell me what is the electric potential? Hello. So the general expression for electric potential is given by V is equals to Q by 4 pi epsilon naught into R. Guys, you remember this now? This is for electric potential due to dipole by for point charges, right? For a point charge, if we have electric potential V is equals to Q by 4 pi epsilon naught into R, then what would be the electric potential due to this point charge plus Q on this point R and due to this minus Q on point R? Guys, try to find what is my V net. If V net is the electric potential at this point, so what could be the value of V net? Really, YouTubers, please try to answer. What is the net potential at this point R? Yes, correct, Hari Prasad. So guys here in Zoom, Tejas, Prakash, Prajwal, Chinmay, try to answer. Guys, what is the electric potential? Say if I have V1 as my potential at due to okay, if I have my V1 as my potential due to minus Q charge and V2 as my potential due to plus Q charge on this at this point R. So what is my net potential? Guys, what will be my net potential? I'm waiting for answers, guys. V net will be equals to yes, V net will be equals to V1 plus V2, right? Guys, reply, try to be active. Hello, guys, try to be active. So this is my net potential. Then try to find what is the value of V1, guys. Tell me what is the value of V1. Everyone, tell me what is the value of V1. YouTubers, please try to answer. So everyone, please try to answer. What is the value of V1? Guys, using the point charge formula, what could be the value of V1? Say if I have only minus charge here, minus Q charge here in the space, and I have a point charge here, R. So what is the potential general expression for V1? V1 will be equals to, yes, it is K times of minus Q by, what is my distance, guys? Tell me. What is my distance from this point R to this point? Yes, it is R plus A. It is R plus A, right? So this is R plus A. So put R plus A. So you got your V1. Similarly, what is V2, guys? Tell me what is your V2? Did we complete this, guys? Did we complete this? Did we complete electric potential for dipole? Reply, please. No, then yeah, please try to answer. No, what is my potential V2, guys? V2 equation ಏನಿರುತ್ತೆ ಹೇಳಿ? V2 will be K times of plus Q or minus Q. Yes, correct, Prakash. It is plus Q by R minus A. Right. Now my V net will be summation of these two, V1 plus V2. Correct, Ramakrishna Reddy. Correct, Aparna. Cool. Mega correct. Total correct. So what we'll do, we'll try to derive the expression for that. So first we'll consider V net is equals to V1 plus V2. That is V net is equals to V into minus Q by R plus A plus of V into plus Q by R minus A. Hope you guys got to know this. Till here, is it clear, guys? Guys, please reply. I need your support. I need your support. Guys, please try to help. Try to solve me. Yes. So, yep. Next, how can I simplify this, guys? You know how to simplify this? Try to simplify this, guys. What is the next step? So what I do, I'll take my K and Q as common in this case. So I'll take K and Q as common. So I'll get 1 by R minus A minus 1 by R plus A now. So if you try to simplify this, what would you get? After cross multiplication and simplifying, we get V net is equals to KQ into R plus A minus R minus A by R minus A into R plus A. Guys, what would this end as? Help me. What can I write this? How can I simplify this? Using your linear equations or linear algebra, tell me what should I do? R plus A into R minus A. You have your identities, right? So this is similar to A plus B into A minus B, right? This simplifies to what? Yes, guys, try to answer. Yes, A square minus B square. So that will be R square minus A square in this case. So my KQ into R plus A minus R minus A will, what happened here, guys? So I have a plus R and a minus R. These two cancel here. Next, in next step, I'll get my K is V net is equals to K times of K into Q into 2 times of A by R square minus A square. Yes. Then, so putting Q is equals to Q into 2A as P, I would get my V net as K times of P by R square minus A square. Okay, this is the general expression, guys. Please make a note of this. This is very important. This is very important. Please make a note of it. So I know this is a derivation. Yes, correct. Yes, correct, Adi Prasad. K times of P by R square minus A square. Correct, Ramakrishna Reddy. Cool. Correct, Meghana. Sorry, Megha. Mesre tapagate ಏನು ಮಾಡೋದು? Okay, now this is expression for electric potential on the axial point. Which point? On axis. On axis. This is for on axis case. Okay. If my R is much more greater than A, we can neglect A. Then we get, okay. Then we get P net is equal to K by, K into P by R square. Okay, this is the expression when we neglect my A. So that is nothing but V net is equals to P by 4 pi epsilon naught R square. So this is the final expression we get when we neglect A, guys. So when can we neglect A, guys? Tell me from yesterday's class. Guys, from yesterday's class, when can we neglect A? Yes, when my dipole is not a short dipole, when my R is much more greater than A, yes, I can neglect A. So comparing the equations, so this is the expression for my electric potential due to at a point. Okay, due to dipole at a point, guys. Yes, correct. So, note in your CBSE, in your NCERT, you had a different expression. So, we have considered this point. This is on axis condition, guys. On the axis condition. So, this is the electric potential on the axis condition. Okay, I'm breaking this into three parts. Derivation of electric potential, I'm breaking into three parts. First part is this on the axis of the dipole. So net potential on the axis of the dipole is kp by r square. Please remember this. Okay, so comparing this equation with the dipole of the dipole point. Okay, comparing this equation of potential energy or electric potential of dipole with the electric potential of point charge, what can we conclude? So we know that axis, the potential at axis is given by Kp by r square, right? See, this is nothing but the electric potential at dipole in the along the axis is given by Kp by r square. So we can write if K and P is constant, we can write potential due to dipole on the axial point is inversely proportional to r square. Then how can we get the graph, guys? Which type of graph do we get? So yesterday while solving graph, I asked you to check for 3 points. What are those? What are the 3 points? R equals to, tell me guys, what are the 3 points? I asked you to check. I asked you to remember when you are checking for graph. You have to remember for 3 points. One is R equals to 0. Second is R is increasing. And third is R tends to infinity. Okay. Should remember these 3 points. Okay. Yep. Then how can we draw the graph, guys? How would we get the graph? How will we get the graph? Which type of graph is it? So we will get a graph something similar to this. So we checked for r equals 0. When we put r equals 0, what happens? When we put r equals to 0 in this expression, v net, my v net will be up to infinity, right? When my r is increasing, my v reduces as square of, yeah, reduces the double time square of r, right? My potential reduces with the factor of square of r. Then in third case, when my r tends to infinity, my v tends to 0. So this is the potential graph, potential versus distance graph for dipole. Okay, this was the graph for dipole. So guys, how would we plot the expression for electric charge, point charge? Tell me how to plot the graph for point charge. Yes. When my r equals to 0, what is the expression, guys? Point charge, what is the expression? V is equals to k times q by r, right? So you have to check for this point. When r equals to 0, what happens? Yes, correct, Devikarani. When r equals 0, I'll get my infinity. Okay. When then when r is increasing, what happens? When my r is increasing, what happens, guys? When my r is increasing, what happens? In this expression, if my r is increasing, what happens to v? Here, draw. Hello. Yes, v decreases. So how will it decrease parabolically, linearly? In which fashion? I mean, in which shape does it decrease? So this is v is inversely proportional to r. V is inversely proportional to r. In which type of graph should I draw here? If my r is increasing, my v decreases. Which type of graph should I draw here? Yes. So v is equals to r is my linear graph. V is equals to 1 by r will be kind of partial linear. So it will, I'll get a curvish but not exactly curve. So not as much as this one. So it won't go as much as this one. So if I want you to draw that, this graph is for dipole, it will be something similar to this. The dotted lines which I'm drawing is for dipole. Okay, the line which I'm drawing, the thick line which I'm drawing is for the electric potential. Okay, now as v tends r tends to infinity, this tends to 0. Okay, this is the expression which we get. So what we can conclude from here, we can conclude the electric potential due to dipole decreases fastest compared to the electric potential due to point charge, correct? Excuse me, guys. So we can conclude the electric potential due to dipole decreases the, sorry, electric field, or yeah, sorry, electric potential due to dipole decreases the fastest compared to the electric field of the point charge, correct? Please reply. Yes, guys, cool. Okay, cool. Yes. In case of dipole, it varies as r square 1 by r square. In case of point charge, it varies as 1 by r. Correct, Amit? Cool. Next, guys. So we'll try to find the electric potential due to equator. Electric potential on the equatorial position. So which is equatorial position? So we'll consider this. So we have two potentials, two charges, Q1 or plus Q and minus Q. We have 2 point charges plus Q and minus Q separated by a fixed distance of 2a. Now, if we consider a point R, if we consider a point R on the midpoint, along the midpoint, say, if if we consider a point R along the midpoint, what do you find? What would be my VR or VNet? Net potential at this point VR. Guys, someone tell me the answer quickly. Tell me the answer quickly. What can you guess? What's the answer is? Can you guess what answer would be? What my answer would be? Hi guys. So is this done in your school, guys? I think this derivation is you might have done in your school with binomial expansion, right? Here we are not using binomial expansion. So we are trying to solve without using binomial expansion, only with the previous knowledge, what we know. Okay. Yes, guys, come on, tell me. What could be the net potential due to this point charge or this point R and due to this point charge on this point R? What is VR? Please reply. V net would be equals to, say if V1 is my potential due to minus Q charge and V2 is my potential due to plus Q charge. So what will be my V net at this point? It will be V1 plus V2, right? Howda? V1 plus V2 irutta? Yes. Yes, cool. Then, yeah, if I consider this distance from this midpoint to the capital R as small r, if I consider the distance from midpoint of the dipoles to this point R as small r, then what is this distance, guys? If this distance is A and if this distance is R, what is this distance? Yes, we apply the Pythagoras theorem and find the expression as square root of r square plus a square. Okay. Next, we have to find the electric potential due to these 2 points at this point. So what is my potential V? General expression was K times Q by R, right? For point charges, if we consider these two as point charges, if I consider point R and minus Q as point charge, then the electric potential due to these 2 points or on this point charge and this, say if I assume there exists a test charge here, what is the electric potential at this point? What do you think the electric potential at this point is? Guys, what does this expression change as? Okay, come on, help me. V is equals to K times of plus Q or minus Q. Okay. So it varies as V is equals to V net. So V is equals to V1 plus V2. So my V net is V1 plus V2. Yes. Then my V net is nothing but K times of minus Q by R square plus A square. Okay. Minus Q by R square plus A square. So if you observe here, what will be my net potential, guys? Why not rapa? Simple agis. Hi Prajwal. See, consider this is a point charge. This is a point charge. Apply point charge potential formula. Step. Are you guys getting confused somewhere? So my net potential at the equatorial point will be 0. Okay. Yes, guys. Is there any confusion? Are you guys feeling any confusion? Or you are not understanding something? Please let me know. Is there any difficulty, guys? Guys, listen. You have to express, or you have to tell us if you have any confusion. Okay, no confusion, right? Please try to respond. No, please try to respond. Please be active. Okay. So we found what was my v-axis. My v-axis at the axial point, my potential was v is equals to k times of q by r square. Hmm? In my previous expression, we found the potential at this point is okay, 2p by 4 pi epsilon naught r square, right? So this was p by r square. This was the electric potential due to dipole on the axial point. Now similarly on the perpendicular point or on the equatorial point, you get v net is equals to 0. Now, so now help me to find what is the electric potential due to dipole at any point. Guys, what do you think the potential due to an electric dipole at any point P? So for this, yes, we need to know both the formulas, potential due to axis and potential at the equatorial point. We should know both the formulas. So this is different from your NCERT textbook derivation, okay? So we'll do simplify that equation very simply. We'll try to simplify that expression. So the net potential at any point can be given as, see, we can use this. So at any point, my electric potential is, say if I consider any point r and theta, say I have my point here. If I want to consider any point, say if this is a point, so how can I consider, if this is my horizontal, this is my horizontal, how can I consider this point? Guys, you can consider this point by moving r distance at an angle theta with respect to horizontal, right? How can I reach this point A? If I want to reach this point A, if I'm standing here, how should I reach? I should turn theta degrees towards that point A. Then I should walk r centimeters or r distance along A. Correct? So this is how I reach my point R, right? So at any point R, which is R with respect to C and theta, R is nothing but the length and theta is nothing but the angle. Okay. So if I consider that, say considering again my 2 point charges separated by a fixed distance of 2a, then if I have any point r, say if I have any point r, so before that, what would be my dipole moment, guys? What would be my dipole moment? Tell me the expression for dipole moment. P equals to q times of 2a. Hoda? P is equals to q times of 2a. In which direction, guys? In which direction do we get the dipole moment? No, why I am unable to check my chat box. Unable to check my chat box, guys. I don't know why. I don't know if you are communicating with me, good guys, but unfortunately, yes, I think I'm able to see now. Okay. Yes, guys, come on. Yeah, I now I think I'm able to see. Yes, it's from minus q to plus q direction. Some minus q direction to plus q direction, right? Now, if we want to find my net potential at any point r, say I have a point r here, guys. I have a point r here. Now help me solve. How can I find my electric potential at this point? How can I find my electric potential at that point r? Tell me that. So I have two dipoles. So one positive charge, one negative charge, and my dipole moment is along minus q to plus q. Now I have a point R. Yes, how can I find it? So how can it be possible as in the direction of electric field, the potential decreases? Yes. So try to consider the equipotential surface here. Say in the previous case, right? If you're asking, if we come to the previous case here, yes, you could check the electric potential due to this point, right? At this point, due to minus q will be in which direction? So my potential, see, my potential is not a vector quantity, it's always a scalar quantity, right? My potential is a scalar quantity. I'll experience a pulling force. Okay, even yeah, if I consider that electric potential due to dipole, yes, I think I have drawn this, right? So guys, I have represent, see, there was no line between C and R. Now I'll consider a line between C and R. This is my dipole distance. Now the net potential at this point, at this point R, sorry, at this point R will be the potential due to minus Q charge and potential due to plus Q charge at any point in this. Guys, not only at this point, if you consider any point in this, my net potential will be zero in all points at the midpoint. Okay, Dhanush. So you get an equipotential surface here, Dhanush. So if you try to draw a plane, if you try to draw a plane at all points in this midpoint, you get, see, if you try to find the electric potential at this midpoint, Dhanush, are you, I hope you are listening. Please try to answer. At this midpoint, if I try to find the electric potential, what is my net potential at this point, Dhanush? Exactly at the midpoint. If you remember, even for 2 point charges, even for 2 point charges of same magnitude, what was the electric field or what was the net electric potential at the midpoint? Electric field was zero. Then if we know E dot dr is equals to V, you know E dot r is equals to V. If E is equals to 0, what will be my V? What will be my V? V will also be 0, right? So at all points at the midpoint, at all points on the equatorial axis or equatorial plane. If I consider a plane here, at all points, I'll get an equipotential surface, okay? My V net or net potential will be always equals to 0 in this condition. Hope you understood, Dhanush. Dhanush, please reply. Yes, cool. So we'll try to find the electric potential at any point now. Now what we have an electric dipole, right? So I can represent these two electric dipoles, I mean these two points or dipoles with a single arrow, that is the P vector, dipole vector P, right? Now if I want to find the electric potential at this point R due to this dipole moment, how can I do it? If I want to find the electric potential at this point R due to this dipole moment, how can I find it? How can I do it? Guys, try to answer. We can, yes, try to resolve the vector, okay? Resolve vector P. So my P is a vector, right? Try to resolve P. What will we get? Guys, please try to resolve P. So if you try to resolve P, you'll get, so if R is the distance between C and point R, then if you try to resolve P, we'll get Yeah, we'll divide the dipole P into its component P cos theta and P sin theta. So at this point, what will we get? So if theta is the angle between them, we get P cos theta at this point. And similarly, if we try to divide along the perpendicular point, what we get? We get P sin theta. Okay, we'll get P sin theta. Now, guys, if you want to find the electric potential at this point R, what should we consider? P cos theta or P sin theta or both? What will be the net potential at this point? So listen, so at this point, my net potential will be due to the electric potential of P cos theta as well as P sin theta. Say in this case, I'll consider these two as, or P sin theta as a dipole set. I'll consider P2 as a dipole on, and this point R is on the equatorial plane, right? Guys, can you imagine? See, for P sin theta, if I consider P sin theta is my dipole, then this point R is on the equatorial plane. Correct? When would I get P sin theta, guys? If I have two poles, dipoles in this direction, if I have minus Q here and plus Q here, I'll get in this direction P sin theta. Now this point R will be on the equatorial plane of this dipole. Correct? Correct or wrong? Please reply. Yes, correct, Hari Prasad. Yep. So if you see, this P cos theta component is along the direction of this point R, and P sin theta component is perpendicular to the direction of point R. Okay, what will be my net potential? My net potential will be the summation of potential due to axial point, that is P cos theta, and potential due to perpendicular point, that is P sin theta. Okay, from here we get my VR is equals to V axis plus V perpendicular, that is VR is equals to VP cos theta plus VP sin theta. Guys, again, what can I write my VP sin theta as? Right, VP sin theta or VP sin theta is nothing but VP, or VP sin theta is nothing but P cos of 90 degree plus theta, right? So if I take P cos theta as 90 degree, what will happen to this? So this point is nothing but we apply the same VR is equals to P cos theta by 4 pi epsilon naught R square plus the same thing P cos theta by 4 pi epsilon naught R square. See, in this case, we don't consider this P, we are not considering the perpendicular factor because this is not at all contributing to the electric field at this point R. But this one, P cos theta, is contributing electric field, is contributing to the electric potential. So my net potential will be equals to V axis plus V perpendicular, that is Vp cos theta plus Vp sin theta. So if I consider sin theta as cos of 90 plus theta, then I'll get 0. Yep. So I'll get this at this direction, I'll get it as 0 since I have cos 90. Okay. Now my net potential, then the final expression would become VR is equals to P cos theta by 4 pi epsilon naught R square. So this is another type of derivation for your electric potential. It's a bit different from your NCRT textbooks. So in your NCRT textbook, you have used binomial theorem, but here we did not use binomial theorem, guys. Binomial theorem is not used, but for your examination purpose, you could follow your textbook only. Okay. Whatever the derivation given in your textbook, so you could follow that. Okay. So this is the expression for electric potential due to an electric dipole on at any point, guys. So can we verify this? Can we verify this expression? Please help me verify this. Say if I want to find on along the axis, what is my theta, guys? Along axis, if I want to verify this, along my axis, what is my theta value? What is my theta value along axis? My theta value is 0 degree, right? Now try to substitute 0. Will we get along axis? Potential due to axis is P cos 0 by 4 pi epsilon naught R square. So what would I get? This is nothing but 1. I'd get P by 4 pi epsilon naught r square. Is this the expression for the potential at axis? Yes, is this the potential? Is this the expression for potential at axis, guys? Yes or no? Is this the expression for potential for axis? Nearly. Yes. Then if you substitute, if you want to find the equatorial point, at equatorial point, what is my potential? Try to find the potential at equatorial point using this formula. So what will be my theta value at equatorial point? Theta will be equals to 90 degree, right? Then I'll get P cos of 90 by 4 pi epsilon naught r square. So this is nothing but 0. So we got back the same expression, right? So we got back the same expression. So this is the general expression for electric potential due to an electric dipole at any point. Okay, guys. Cool. Understood this? Yes, correct, Hari Prasad. Cool. Okay, guys, come on, let's. So the next we have dipole in an electric field. So what happens? Suppose if we have a dipole in an electric field, so we'll consider an electric field E. Let E be the electric field uniform. Let E be the uniform electric field. Then, in the presence of uniform electric field, I'll consider a I'll consider a dipole. Now, what happens, guys? This electric field is due to a point charge. I mean, this electric field is due to a plus Q source charge, right? This electric field is due to a source charge which is positive. Hoda? Please reply. The electric field E is due to a positive charge. Now, what happens to this positive charge? What happens to this positive charge? In which it experiences a force, right? Any point charge, say this is of plus Q and this is of minus Q. Now, yes, it repels. It repels. So in which direction it's pushed? So my point charge, the positive point charge, is pushed in this rightward direction, and my negative charge is being attracted towards the electric field. So it experiences a force of minus F, right? Now, what is the net force on this point? What is the net force experienced at the midpoint of the dipole? Guys, what is the net force experienced on the midpoint of dipole? Suppose there is no torque. I mean, I'm not asking about the torque condition. I'm asking about the net force acting at the midpoint condition. In midpoint, what is the net force? Yes, correct, Tejas. So at midpoint, my F net is F plus of minus F. That is, F net is, we know F is equals to Q times of E. F is equals to Q times of E. Then F net is equals to QE plus of minus QE, that is 0. Then the net force acting on a dipole at the midpoint of dipole is 0, but there exists a torque between the dipole. So how in what direction would I get my torque? So what is the torque, guys? What is the general expression for torque? Torque tau is equals to, what is the general expression for torque? We learned in 11th, right? Torque tau is equals to, yes, force into displacement or force into perpendicular distance. Guys, my torque tau is equals to force into perpendicular distance, which we had studied in our 11th standard, the basic definition of torque, right? So then in this expression, in this image, where is my torque? So if F is the force and if this is separated by a distance of 2a, then if I keep my one of the charge fixed, yes, if I keep my one of the charge fixed, then my torque tau is equals to force times of 2a, right? Now, yes, correct, 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 Devikarani, correct, guys. Everyone, okay, you were telling P is the dipole moment and E, right? Cool. Thanks, guys. Thanks for the reply. So if I try to simplify, that will be equals to 2a times of Q into E. Now this is nothing but P cross E, guys. Everyone missed this cross product. So that's why I was not able to get that P into E. Everyone missed your cross product, or it was supposed to P dot E. Right, correct, Prakash Goda. Cool. Sorry, P cross E. This is supposed to be P cross E. Always. Guys, if this is a cross product, what was the direction of my torque? So if this is my electric field, and my dipoles are in this direction, say this is my dipole, one positive charge is going here, negative charge is going here. So in which direction is my torque, guys? In which direction is my torque? Perpendicular to what, Anusha? In which direction is my torque? Okay, it's in P cross E. Suppose if I consider this is I cap, this is going upwards is J cap. Suppose if I consider I J K cap. So I cap, J cap, and K cap. So in which direction would you say my electric dipole is? I mean dipole torque is? Yes, correct, Tejas. So in terms of I cap, J cap, and K cap, what would you say? See, guys, using this screw rule, the right hand screw rule, or using the expression. So how can I tell my electric dipole direction? So if I move in the direction of my potential and curl in the direction of electric field. If I move in the direction of potential and curl in the direction of potential, I'll get my torque in this direction, right? So my potential is in this direction, electric field is in this direction. Then in which direction will the torque move? So right hand screw rule, guys. Hope you remember right hand screw rule. So if this is moving, my dipole moment is moving in this direction, my electric field is in this direction, P cross of E. So if I had a screw here, in which direction it would move? If I had a screw here, in which direction it would move? Would it move inwards or outwards? So this is the right hand screw rule, right, guys, right? So my electric potential torque is inwards, right? So which type, what is the direction for torque, guys? Then what's the direction for torque? My torque is given, yeah, my torque is given inwards, that is minus K cap. So if this is I cap, this is J cap, and outwards is K cap, then inwards should be minus K cap. Okay. Potential or the net dipole torque would be inwards. So the torque due to the uniform dipole, the torque due to the uniform electric field on the dipole is given by P cross E or PE sin theta, right? A cross B is AB sin theta. So P cross E is PE sin theta. So if theta is 90 degree, we get torque is maximum. If theta is 0 degree, we get torque is minimum. Guys, hope you guys have understood this expression for torque, or what happens when when a dipole is in an external electric field. So torque is equals to dipole moment times of electric field. Okay, this is the expression. Please remember this. Torque is equals to dipole moment times of electric field into sin theta, or tau E is equals to P cross E. Okay. Yes, also 180 degree. Chinmay, that happens when my, so when would I get 180 degree also? See, 180 degree is not 0, right? Chinmay, this is 0 degree. This is my 180 degree. Sorry, 0 degree, 180 degree. See, it's opposite to each other in my. So that's the difference. Okay, guys, if you have understood, please try to solve this question. So consider an electric dipole with dipole moment of 4 into 10 power minus 9 coulomb meter is aligned at an angle of 30 degree with the direction of uniform electric field of magnitude 5 in with the direction of electric field. Okay, my dipole moment is along the direction of electric field with 4 into 10 power minus 9 coulomb meter, making an angle of 30 degree, and my electric field magnitude is 5 into 10 power 4 newtons per coulomb. Now calculate the magnitude of the torque acting on the dipole. What is my torque? What is my tau? So guys, I hope everyone have understood. Please try to answer. What is my tau? Tau is equals to, or tau E equals to, we know tau E is equals to P cross E, right? Answer guys. So we know the value of P, we know the value of E, we know they have given theta. What is the formula, or you know the formula? Try to apply and solve this. Yes, correct, Anusha. Yes, Dhanush. Please try to answer in the poll, guys. All Zoom audience, please try to answer in the poll. Yes, correct, Ramakrishna. Ramakrishna, ready, correct. Okay, guys. So far, very less number of students have responded. Please, yes, correct, Hariprasad. Yes, correct, Prajwal. So please try to simplify that, guys. Hariprasad, try to simplify and answer. Hariprasad, try to simplify and answer. Yes, correct, Hariprasad. Cool. So, guys, yes, shall we solve? Tau E is equals to P cross E, that is P E sine theta, right? P E sine theta. Now, what is my tau E? That is P. What is my dipole moment? P is 4 into 10 power minus 9 kilometer into my electric field E is 5 into 10 power 4 newtons per coulomb. And what is my theta, guys? Theta is 30 degrees. So I should get my sine 30 degree. What is sine 30 degree? So this is nothing but 4 into 5, 20 into 10 power minus 9 plus 10 power 4. So minus 9 plus 4 is 10 power minus 5. Sine 30 is 1 by 2. What happens here, guys? 2 tens are, that is tau E equals to 10 into 10 power minus 5. So this should be equals to 1 into 10 power minus 4. Yes, cool, guys, awesome. So this, yes, correct, Prajwal. Thank you. Thanks for your answer, guys. It's Newton meter. So your answer is option A. Right? Most of you have answered this. Okay, cool. Okay, sorry, I forgot. I think I forgot to give negative power here. Okay, this is option A. Option A is the right answer. Okay, guys, cool. Thank you. Then we'll try to solve. Okay, we'll try to derive an expression for potential energy in an external electric field. Now, again, we have considered the same electric field, uniform electric field, due to for this dipole with the dipole moment A P and separation of distance 2a. For this dipole separated by a distance of 2a, we have the dipole moment P, and the force experienced by this dipoles, the positive charge is along this direction with capital F, and negative charges along this direction with capital F. Now, what is the say? Now, if I don't apply, if I leave them, what will happen, guys? What will happen to these dipoles? So dipole ಏನಾಗುತ್ತೆ if I don't if I leave them as it is in the presence of electric field. So what happens, guys? They will experience torque, right? Tell me what happens here. What happens here? So if I don't apply any force, if I don't, if I leave them, if I leave the dipole as it is in the presence of electric field, what happens, guys? Tell me, come on, try to answer. Yes, if I leave them, they experience a torque, right? They experience a torque in the presence of, yes, yes, correct, Girish. So they won't move to, so they experience a torque, right? Since they experience a torque, they rotate in this direction. Hola. They will try to rotate in this direction. And after some time, what happens? So in the presence of electric field E, my dipoles, my dipoles will align in this direction. My dipoles will align in this direction, and there won't be net force at all. I mean, the net force F net will be zero in this case. See, this will try to pull here, this will try to pull here, push here. There will be no net force. See, there will be a negative force, or there will be a pulling force on this negative charge and a pushing force on this positive charge. What is the net force, guys, in that case? What will be the net force between these two dipoles? Hello. So net force will be zero. This will stay like this forever, right? So if I don't want this to happen, what should I do? Yes, it will align in a straight line. Correct, Prajwal. Correct, Aparna. Correct, Prajwal. So if I don't want this to happen, what should I do? If I don't want this to happen, what should I do? I should apply some force, right? I should apply in force, some force to stop them from rotating, right? In which direction should I apply force? Yes, net force is zero. So in which direction should I apply force such that they don't rotate at all? So I should apply some torque, right? We know that the torque experienced by dipole in uniform electric field is tau is equals to P sin theta in minus k cap direction, right? Now what happens if I don't, if I leave the poles as it is, if I leave the dipole as it is, this will try to rotate and they stay there forever. If I don't want that to happen, what should I do? I'll apply force in the opposite direction, right? I should apply some force in the opposite direction such that these two doesn't move at all. So I'll apply some force in this direction, which I marked in my green pen. So I'll apply force in this direction so that my dipoles won't form as, don't come to horizontal line, right? So I'll try to push this. To push this, what I'll do, I have to put some external torque. Have to put some external torque. Have to apply some external torque, right, guys? So what will this external torque, or what is my torque, guys? Torque is force times of perpendicular distance, right? My torque is force times of perpendicular distance. When I apply this amount of torque, so this is also equal to what? This external torque is also equal to what? The external torque which I'm applying to put these dipoles in a position, in their initial position, is given by tau is equals to F multiplied by perpendicular distance. Now, what is this external torque which I am applying? Yes, this is also the work done. Correct, Tejas. This is also the work done, right? So when I'm up on the amount of okay, what is the amount of torque I have to apply, guys? This we had solved in our very first class in the beginning for point charges, 2 point charges when we were calculating potential, right? So we have to apply the same amount of external torque in the opposite direction. Say if my torque is in this direction, I have to apply the external torque in the opposite direction. So this is equal to the amount of work done. So this is the amount of external work done on the dipole. What happens to this external work done on the dipole? What happens to this work? It will be stored as potential energy, right? So the external work done on the dipole is given by W external is equals to integral of theta 1 to theta 2. So we are applying some work. So initially my dipole was in one position and it tried to bend in other position. So what happened? There was uniform electric field here. So in this presence of uniform electric field, I had a dipole, right? I had a dipole of magnitude P. So this dipole made an angle theta in the initial case. Now, under the influence of the electric field, it tried to move, right? It tried to rotate. Under the influence of electric field, it tried to rotate. Now, consider it rotated in some angle theta. Consider this dipole made an angle theta with the horizontal. Okay, made an angle, additional angle theta 1. Now, so it made an angle theta 2. So now I have to bring, say, let's consider this as theta 1 only. Now I have to bring this dipole from theta 1 position to initial position theta 2. Okay, I have to do some external work done. So that is given by W external is equal to integral of theta 1 to theta 2 with how much magnitude? With torque external. So if we try to simplify this, we'll get W external is equals to integral of theta 1 to theta 2 minus PE sine theta. Okay, we'll get it as integral of theta 1 to theta 2 minus PE sine theta. What was my torque external? Tau E was P cross E. If you remember, that is my PE sine theta. So that was my external work done. Also, the external torque applied. So if I try to simplify, try to integrate, guys, try to integrate. What is my integral of sine theta? What is my integral of sine theta? Okay, I'll get minus of cos theta, right? Okay, I think I substituted minus already. So yes, integral of sine theta was minus of cos theta. ಇಲ್ಲಿ minus ಬರ್ಬಾರ್ದಿತ್ತು. Okay, integral of sine theta is minus of cos theta. So I get this cos theta. Okay, anyway, keep it as it is. Now, if you try to simplify, you will get W external is equals to minus of P cos theta minus of minus PE cos theta 2 minus of minus P cos theta 1. So you'll get W external is equals to PE cos theta 1 minus cos theta 2. Okay. So this is the general expression for your external work done. Now, under the conservative force, what can we say? Or here in this case, it's not conservative force, it's conservative torque. Under conservative torque, so we can say my change in potential energy is nothing but the amount of external work done. We can say the change in potential energy is equals to amount of external work done, right? So this is the expression for the external work done. Now what about the potential energy? So this is the change in potential energy. So the potential change in potential energy is given as PE cos theta 2 minus cos theta 1. Sorry, cos theta 1 minus cos theta 2. So U is equals to PE minus of PE cos theta. Okay, we'll check that. Right. Anyway, it's there here. So for theta is equal to 0 degree, my potential energy will be 0. For theta equals to 90 degree, my potential energy will be 0. then my potential electric potential energy will be given as minus P cos theta. Correct, Anusha? So this is the expression for my potential energy. It is U of theta is equals to minus P cos theta. Okay. Or U of theta is equals to minus P dot E. Okay, again minus U theta equals to P dot E. Okay. This is the general expression which we get for potential energy, guys. So hope you guys have understood this. Click on S if you have understood this. Yes, no, really. Okay, cool. So try to find this, guys. So consider an electric dipole placed in a uniform electric field as shown in the figure. At what value of theta will the system have minimum potential energy? So please try to answer this. At what value of theta will be will the system have minimum potential energy? No, Hari Prasad. See, we had cos values, right? For cos theta equals to 90 degree, cos theta cos 90 was 0. For cos theta is equal to 0 degree, we'll have maximum work. Yes, correct, Anusha. Cool. Ouch. So guys, please remember, check your answer, Hari Prasad. Tejas, check your answer. So they are asking, at what point will I get my minimum potential energy? So in what condition will I get the minimum potential energy? Okay. Guys, what is the expression for see? What is the expression for potential energy? U is equals to PE minus of PE cos theta, right? So guys, please remember there is a negative sign. Remember there is a negative sign. U is equals to minus of PE cos theta. So for minimum potential energy, what should be the value of theta? I think everyone is forgetting the negative sign. Please don't forget negative sign. U is equals to minus of P cos theta. Yes, guys. Now you are correct. I hope everyone is getting that. So don't miss the negative sign, okay? Yes. So I'm going to end the poll. So most of you had given me the right answer. The answer is option A. Oh, I didn't put. So answer is option A, guys. Why? We know U is equals to minus of P cos theta, not only cos theta, it's minus of P cos theta. If my theta is equal to 0, then my cos theta will be equals to 1. Then my U will be negative, right? My U will be negative, so it will be minimum. So if my theta is 90 degree, what happens? My cos theta will be equals to 0. Then my U will be equals to 0. So compared to negative, my U will be more, right? U will be maximum. So B is not a right option. Even pi is not a right option. So correct option is theta equals 0 degree. Okay. Guys, understood this one? Please click on S if you have understood. Please click on S if you have understood. Yes. Cool. Okay. Now guys, try to solve this question. So there are 2 point charges. There are 2 point charges of 3.2 into 10 power minus 19 coulomb and minus 3.2 into 10 power minus 19 coulomb, separated from each other by a distance of 2.4 into 10 power minus 10 meter. Okay. The dipole is situated in a uniform electric field of E is equals to 4 into 10 power 5 volts per meter. Calculate the work done in rotating the dipole by 180 degrees. Okay. So initially dipole moment was parallel to the direction of electric field. Guys, note this. This is very, very important. Initially dipole moment was parallel to the direction of electric field. See, did you guys get the question, guys? Excuse me. Hari Prasad, so at theta equals 0 degree and 90 degree, work done is 0. No, Hari Prasad. At theta equals 0 degree, work done will be maximum. At theta equals 90 degree, work done will be minimum. So, but that differs on the case. From case to case, it differs. Okay. So in previous case, in this question, what was happening? We know U is equals to minus of P cos theta. When theta was 0 degree, my cos theta was 1. Then my potential energy was maximum compared to this, right? So sorry, minimum when compared to 0 degree, right? So U was minimum, U was negative in this condition. When theta becomes 90 degree, my cos theta will be 0, then U will be 0. Okay. So what do you mean by this? So if you have U, suppose if your theta is 180 degree, then you will get U as the maximum, highest one. Okay. Yes. So at theta is equal to 0 degree and 90 degree, work done is not 0. Okay, guys, come on. Others, please try to answer this. There are 2 point charges of minus 3.2. Hope everyone got the question. Did you get the question? So there is some uniform electric field E of magnitude 4 into 10 power 5 volt per meter. So they have given E as 4 into 10 power 5 volt per meter. Okay. So Hari Prasad, your question, W is equals to minus of PE, right? I'll come back to that, Hari Prasad. Wait, let me explain this question first. So I have electric field E is equals to 4 into 10 power 5 volt per meter. Now, what's happening? What they have given in the question? They have given there exists a dipole which is already in this way. So the dipole moment is in this direction, parallel to that of my electric field. They have mentioned the dipole moment is parallel to that of electric field. Now, if I have to completely rotate this dipole by 180 degrees, what amount of force should I apply? What amount of torque should I apply? This is the question. If I have to completely rotate it by 180 degrees, what is the amount of force I have to apply? Mega, no. Tejas correct. Mega, wrong answer. Tejas correct. Tejas correct. Mega, please check. So, if you could try to answer in your polls. Okay, Hari Prasad, coming to your question. Okay, I'll discuss your question after this problem, Hari Prasad. Okay. Guys, try to solve this. Tejas correct, Prajwal correct, Prajwal EM correct. Guys, which formula are you going to use here in this case? Guys, try to solve fast. I mean, we will be discussing more. We can discuss more questions if you try to solve fast. Yes. Okay, guys, come on, let's solve this question then. I'm going to end the poll. How many have answered? So only. Oh my god. Try to answer, guys. Okay, so which? Okay, correct. Rajwal, Mega, correct. YouTubers, are you trying to solve? Please try to answer. Hello, guys. Please try to answer in YouTube. I didn't get any response so far. Yes, guys. Which formula are we going to apply here? Come on, tell me. So I'm going to end the poll, guys. I waited for so long, and so some 4, 5, 6 students have answered. That's correct, Bhargav. Cool. So, guys, let's try to solve this question. No? So, what's given to us? We have given the work done. We have to find what is the work done. W. So, we know W is equals to what? Work done or work external. W external is equals to minus integral of theta 1 to theta 2, right? Theta 1 to theta 2 tau dot d theta. So guys, what is my theta 1 here? What is my theta 1 here? 0 degrees or 180 degree? Tell me what is my theta 1 here? 0 na 180 na? 0 degree na 180 degree na? Theta 1 is 0 degree and theta 2 is 180 degree. I have to move from parallel to anti-parallel, right? So what is my tau, guys? What is my torque given? We know torque tau is equals to P cross E, or tau is equals to PE sin theta. Okay, so what were all given to us? We have given with E and P and Q. Sorry, we are given with 2A. 2A is equals to 2.4 into 10 power minus 10. 10 power minus 10 meters. Q is equals to 3.2 into 10 power minus 19, sorry, minus 19 coulomb. And what else? E, electric field E is equals to 4 into 10 power 5 volts per meter. So these were given to us. Now first, what should we find? We should find P. What is the value of P, guys? P is equals to Q times of 2A. Now tell me what is the value of P? What is the value of P? Really? We'll get how much? Okay, let's try to integrate first. Okay, so if we solve this, it will be helpful for us somewhere, but let's try to integrate then. Or if you want to solve now, we can solve here. 2 into 3.2. So guys, what is given in the question? So are separated from each other by 2 into 10 power minus 10, right? Correct, yes. 2a. So integration, so we have to do the integration. W external is equals to integral of 0 to 180 degree. So I'll keep my P as for now as PE only, sin theta d theta. If I try to integrate, what would I get? I get W external is equals to PE cos theta minus P cos theta So there was already a negative sign. So this minus and this minus, yes, I'll get cancelled. So I will write PE cos theta only. So my P cos theta was P cos theta 1 minus cos theta 2, right? So how to write this? P into cos theta 1 minus cos of theta 2. ಚಿನ್ಮಯ್ ಏನೋ ಬರ್ದಿರ ನಂಗೆ ಅರ್ಥ ಆಗ್ತಿಲ್ಲ. Okay, now guys, what is cos 0? So I'll directly substitute the values of theta 1 and theta 2. Okay, what is my cos 0 and cos 180? So my W external will be equals to PE times of 1 minus of minus 1. My cos 180 is minus 1. So I think Hari Prasad, even this was your doubt, right? When my 0 and 180, when my theta is 0 and 180, what will happen to work done? Please listen carefully, Hari Prasad. So PE times of 1 plus 1, that is 2. I'll get 2 times of PE, right? 2 times of P. From here, I know my P value is, so guys, please make a note, 7.68. Okay, my P value is 7.68 coulomb meter. So I have got my P value. I have got my E value. There is E value, P value, and W external is given as 2 times of PE. Solve this. 2 into 7.68 into, so we didn't solve the powers, guys. Note that we didn't solve the powers. That was 10 power minus 19 into 10 power 10. What will this become? Okay, 10 power minus 29, right? Minus minus, yes, correct. Into 10 power minus 29 into 4 into 10 power 5. Try to solve this. What will we get? You will get 61.44. Okay, if you multiply these, you will get 61.44 into 10 power 20, minus 29 minus plus 5. Yes, minus 24. Okay, thank you guys. So if I'm multiplying one more to satisfy my given equation, so yes, I'll get C. So I got 61.44, right? If I want to find which one suits best, I would get 6.1 into 10 power minus 23 joules. So option C is my correct answer. Okay, artha agidya idu? Hope you guys understood this question, how to solve this. Hope everyone understood. Yes. Cool guys, then we'll wind up for today. Please take the poll for your teachers and PS. Okay guys, at YouTube, we'll meet again tomorrow. So we'll check tomorrow, guys. I mean, in our next class. Okay. So Zoom people, please be in the call. Don't disconnect. Please try to give your feedback there, and please don't leave the chat. Stay back.